Good evening, everyone. My name is Vivek Vardhanedi. Today I am going to present you about Peephole optimization. What is a compiler optimization? Compiler optimization is a process that attempts to improve the code generated by a compiler for better efficiency, speed, or size. It transforms the code without changing its external behavior. Goal efficiency using execution time and resource consumption. Goal speed maximizing the program's throughput and responsiveness. Let's suppose the goal is size, minimizing the memory footprint of the compiled binary. Introducing Peephole optimization, a localized approach. Peephole optimization is a technique performed on a small moving peephole of instructions, a small limited sequence of target code instructions. It's a local form of optimization, meaning it only considers a few instructions at the time, making it simple, fast, and highly effective for small scale improvements. Focus on the target code. Apply directly to the assemble or intermediate code, not the source code. Window-based analysis examines a small block of 3 to 5 instructions. How people optimization works. Pattern matching and replacement. A core mechanism relies on identifying specific inefficient patterns in the code within the peephole and replacing them with shorter or faster equivalent sequences. Identify target code. A window of instructions, the peephole is selected from the generated code. Pattern matching. The instructions are checked against a predefined library or inefficient code patterns. Replacement. If a match is found, the efficient sequence is replaced by a more efficient, semantically equivalent sequence. Iterate. The peephole window slides and the process repeats until no further improvement can be common optimization techniques. Example in action. Redundant load and stores elimination. If a value is loaded into a register and immediately stored back without modification, the redundant operations are removed. Example, load R1, comma A, store A, comma R1. Becomes just load R1, comma A if A is not modified elsewhere. Strength reducing. Replacing cost instructions with cheaper equivalents. For example, multiply R1 hash 2 becomes shift left R1 of hash 1. Constant folding. Recalculating expressions involving constant during compilation. Add R1, comma hashtag 5. Add R1, comma hashtag 3 becomes add R1, comma hashtag 8. Unreachable code removal. Eliminating instructions that can never be executed, such as code immediately follows an unconditional. Advantages of peephole optimization. Simplicity of implementation because it only looks at the small window. The logic for finding and replacing patterns seems straightforward to implement. Machine-dependent qualities. Optimization can be highly specific and tailored to the instruction set of the target's machine, leading to highly efficient code. Fast execution. The localized nature ensures the completion process remains quick as complex data flow analysis is updated. Complementary nature. It acts as a final cleanup phase after other, more complex global optimizations have been performed. Limitations and challenges when Peephole isn't enough. Peephole. Local fixes only small window view. When it comes to global, whole program analysis, cross module scope. While efficiency for minor cleanup, people automation cannot address inefficiencies that spans larger sections of code or involve complex data dependencies. A limited scope cannot perform global optimizations like loop invariant code motion or induction variable elimination. Real world applications where people optimization science. People optimization is standard component in virtually every modern compiler tool chain. Processor specific tuning, embedded systems, post global cleanup. Best practices for implementing people optimization. Iterative passes, comprehensive pattern database, prioritize impact. Takeaways and future scope. First one, localized power. Next, the speed gain potential. Standard practice. Thank you.